Hello and welcome to the second session of IoT ecosystem. IoT ecosystem is just like how exactly the IoT system is deployed and what are the factors that are present inside the IoT that I'll be showing in this particular session onwards. Now, let's see. We are a complete IoT ecosystem I just shown over here. We'll start from this part. Here we have the IoT devices. Okay, so they are the IoT devices. IoT devices are just right, they are the part of the sensors mechanisms where you used to input the data from there. So multiple sensors I'll be having over here. They are used to send the command and they are sending a data based on that. So here IoT devices are present. They are used to sense the data. They are used to collect the data from the particular environment. Okay, now once the data is collected, so that data will be collected at a central hub that we call as IoT hub. IoT hub is just an electronic device where which is used to control all these IoT devices. If you consider the current scenario, lot many devices like Arduino microcontroller or Raspberry Pi microprocessor chip device, so they are present or that can be considered the IoT hub. So where all these devices are connected. So these devices can't communicate with each other, but they will be communicating with the IoT hub here. They will send the command or they will receive the command and they will send a data based on their given command. So their on off activities, their data communication activities will be controlled by the IoT hub. So IoT hub is a hardware device which will be used over here now, and they are also hardware. So now after, so till this only the hardware communication is established. Okay, main part. After that, we are going to make use of the network here. So after IoT hub data is collected, so this data will be given to the company, the data center, with the help of the internet. So here I am making use of the internet network. This internet network will fetch a command to IoT hub. Then IoT hub will give this command to IoT devices. Data will be collected, and that data will be fetched from IoT devices to the internet network. IoT hub is a smart device which will contain the capability to control the IoT devices or to send automated data to the IoT devices. That's it. Okay, that's also it contains, and even it contains ability to transfer this data through the cloud to the user interface or the companies. Okay, now internet network or internet will be present or any kind of network will be present. So basically, if you are having this system installed inside the industry, internet is present there. That's why I given the name as here business intelligence, that is BI intelligence present here. Okay, so internet network, and then this data which is sent over here is collected at the company's platform. So we'll be having a data center or they'll be having a centralized cloud where this data will be collected. Okay, centralized cloud where the data will be collected here. So that's what the IoT's company platform present over here, data will be collected. And here we have IoT remote. IoT remote is the user interface present in this IoT ecosystem where they can see the data, they can control the data, and the other operation that user can do will be controlled by the IoT remote. Okay, so we have IoT remote, and that IoT remote is under the control of administrator of this system. Administrator will decide what should happen in the system. So if administrator want to perform some operations for requesting the information, so will send a command to the IoT device through the network. Then the command will be given to IoT hub, then will fetch to the IoT device. It will reply back with this data and internet connections. Then this data will go to the IoT company's platform, and from there we'll receive the analytical information in the IoT remote. Analytical, like for example, I want to visualize the temperature changes in this particular system. So for example, this is the temperature sensors. It will reply with the data. This data will go in this direction at company's centers, and from this data center I'll see that data in the form of a visualized, like whether temperature is rising or constant or decreasing. So all these things we can easily see with the help of the IoT remote. So IoT remote will be the control mechanism in the system. So this remote can be created as a dashboard on the web system, or I can have an Android application by which you can control the systems, or any web interface can be also possible in your local system. That's also we can make use of it. This is how IoT ecosystem actually works, and how it is connected with the industrial systems. That's what the summary of the particular architecture is shown over here. Now, how it is structuring, how the IoT is structured. So that we are going to see now. The IoT can be viewed as a gigantic network consisting of networks of devices and computers connected to a series of intermediate technologies, where numerous technologies like RFID wireless connections may act as enablers for this connectivity. Okay, so all this giant network of the devices, or almost everything we consider internet. Internet is a connection of all the networks, all the network of networks, like, and IoT is network of networks plus network of things. Like, all they are connected together, they can easily exchange the data, they can communicate with each other. That's what it contains. Now, few four things that you need to consider under the structure of IoT. First, tagging the things. Now, tagging the things, we apply the real-time item traceability and addressability to RFID. So, identification, addressability that we have seen, that's possible. So, we tag the things in the IoT. That's compulsory. Without tagging, without assigning the addresses, it is not possible to identify a particular things in the IoT devices. Now, filling the things. So obviously we have seen the sensors act as the primary devices to collect data from the environment. That's what I told. Data collection from the environment is done with the help of the Sensors will convert that data into form of electrical signals, which will be identifiable by the computer systems. That's what we feel the things. Okay, now shrinking the things. Shrinking is very important, because if the devices are large, see, if you consider a computer in the IoT, a computer or laptop is a very big thing. Okay, that can be considered, but we have to minimize the size of it. So that miniaturization and then technology has provoked the ability of smaller things to interact and connect with the things or the smart devices. Today we are in the generation of nanotechnology. So almost all the things are present there, but their size we are going to decrease. From last several years, we have seen that. For example, you might be knowing the Moore's law, Gordon Moore's law. The evolution of the microprocessor has completed 50 years. Okay, last year, 50 years almost, and in 50 years we have seen generation of microprocessors, where we start with the 4-bit microprocessor till we are going to we are having 64-bit microprocessor today, and almost after 2 years we are going to have 128-bit microprocessors. Now, in this, the number of transistors used in the computer fields are in that particular chip are increasing with very large speed, with very high speed, but the physical size of the microprocessor is not much changing. We are having billions of transistors today, but still the size of microprocessor is almost same. That was used almost 30 years ago. So what we do, we are miniaturizing the devices, but the capabilities are improving enormously. That's what we require in the IoT also. We have to shrink the things so that a small IoT device can be created, connected. Okay, thinking the thing, the most important part of this IoT. Think how that can think. Embedded intelligence on devices through sensors has formed a network connection to the internet. It makes things realizing the intelligence control, just like the example which I told about the temperature control systems. Temperature control systems. Okay, so the temperature control systems are just like automatically we are going to sense the temperature, and as temperature rises above 30 degree, your AC will start. Where we have the interaction of user over here? No, it means that this system is intelligent. The system is capable of making the decisions of its own. That's what think means. So this thinking, this artificial intelligence to the IoT device is given by users to them. That's why they are capable of thinking it. That's very important part. When you consider any industrial IoT application, you need to consider whether the thinking ability is given to that particular structure or not, and that can be given by a programming logic, and that must be there with you. If you are not, if you're aware that if you think that programming is not required in IoT, it's an hardware, connect them and make them think, it's not possible. AI is the programming part. That programming should be done by you, and you have to make use of this particular programming ability. With the help of this programming ability, it's possible to program your IoT device, and it's possible to make it more intelligent IoT device there. Now, what are the key features that industrial IoT or IoT basically contains? So, top features I've extracted that I've shown over here. Just recently, we talked about the AI, artificial intelligence. IoT essentially makes virtually anything smart, meaning it enhances every aspect of life with the power of data collection, AI, algorithms, and networks. It means something as simple as enhancing your refrigerator and cabinets to detect when the milk or favorite cereal runs low and then place the order with your preferred grocer automatically, everything. So we provide intelligence to them. We make this system smart, smarter, and smartest with the help of AI, or we can make use of a machine learning algorithm also to make it more smarter. Okay, connectivity. Now connectivity is again the core feature that the IoT system contains. New enabling technologies for networking, and specifically IoT networking means networks are no longer exclusively tied to major providers. Networks can exist on much smaller and cheaper scale while still being practical. IoT creates these small networks between its system devices. Anything, if you want to communicate between two non-living things, not non-electronic things, they also can communicate with each other. They also can communicate with each other. Just we can make use of a sensor. For example, two devices are there. IoT identified whether these two non-living things are coming closer to each other or not. So I can make use of an IR sensor with the help of infrared. I can measure the distance between them, and as they come closest with the distance of 5 centimeters only, we can report them. Now we are closer. We can buzz an alarm. We can buzz an any kind. You can report them, and we can ask them to stop now. So making them smarter with the help of connectivity systems. Okay, that's what the main feature that contains. Three more sensors. Most important part is that IoT loses its distinction without sensors. They are acting as a defining instrument which transforms IoT from a standard passive network to devices into an active system capable of real-world integration. So the passive network is converted in the form of active network with the help of sensors. I'll show the sensors now. After that, how they are actually being used. Active engagement. Much of today's interaction with connected technology happens through a passive engagement. They are connected but not actively introduced in that. So active engagement is possible. What introduces a new paradigm for active content, product, or service engagement. And the most important part, the last one, small devices. Devices, as predicted, have become smarter, cheaper, and more powerful over the time. IoT exploits purpose built small devices to deliver its precision, scalability, and versatility. Okay, so smallest devices are present possible, and their communication is also possible with the help of the IoT communication system and the mechanism. So these are the common key features that the IoT system is having. So that's from the second session of this FDP. We'll continue the third session afterwards. Thank you. Thanks a lot.